Hello everyone, welcome to Enviro Pioneers. In this video, we will explore why the speed of sound varies in different medium. Our first lecture in the noise pollution ended at this table. There are two important points to note here that the speed of sound varies with the medium. It is maximum in the solid, then उससे कम liquid में और सबसे कम gases में. And second point कि within a particular medium जो speed है that varies as per the component as well as with the temperature. यहाँ पे अगर हम गैसेस में देखें तो सबसे ज्यादा स्पीड जो है दैट इज फॉर द हाइड्रोजन एट 27 डिग्री सेल्सियस एंड देन अगर हम हीलियम और मीथेन नाइट्रोजन को देखें तो यहाँ स्पीड कम होती जा रही है एंड देन फॉर ड्राई एयर अगर हम नोटिस करें तो ड्राई एयर 25 डिग्री सेल्सियस पे 346 मीटर पर सेकेंड एंड देन फॉर ड्राई एयर 20 डिग्री सेल्सियस इट इज 343 meter per second. And likewise for the liquids, we are having here 5 example, and within these 5 example, it is maximum for the sea water that is 1534 meter per second. Likewise for the solids at the room temperature, here we have the different example जिसमें सबसे ज़्यादा टाइटेनियम में यहाँ पे है 6070 meter per second and it is minimum in the rubber that is 1600 meter per second. तो ये जो वेरिएशन है कि सबसे ज्यादा सॉलिड में फिर लिक्विड में एंड गैसेस में अब विद इन अ पर्टिकुलर मीडियम ऑल्सो देर इज वेरिएशन ये क्यों होता है उसको हम समझते हैं यहाँ पे साउंड इट ट्रेवल्स एट 343 मीटर पर सेकेंड इन एयर एंड 1481 मीटर पर सेकेंड इन वाटर जो कि 4.3 टाइम्स लगभग ज्यादा है इन कंपेरिजन टू दिस. And in iron, the speed of sound is 5120 meter per second, which is about 15 times as fast. And यही चीज अगर हम डायमंड में देखें तो in diamond speed of sound is 12,000 meter per second, जो कि nearly 35 times ज्यादा है that of speed in air. Sound travel faster in solid in comparison to the liquid and gases because the molecules in solids are tightly packed and have the strong intermolecular forces which allow the vibration and energy to be transmitted more quickly. Here we can see that in solid, the molecules are closely packed and are arranged in a regular ordered structure. In liquid, molecules are close, lekin they are having the less order and they can move around freely. While in the gases, the molecules are far apart and they can move randomly. And if we talk about the intermolecular force, so solid have the strong intermolecular forces which hold the molecule in place. In liquid, it is weaker and in gases, it is virtually none. As sound is a vibration of kinetic energy passing from molecule to molecule, so the closer the molecules are to each other and the tighter their bond is, उतना ही कम समय लगेगा इस वाइब्रेशन एनर्जी को एक मॉलिक्यूल से दूसरे मॉलिक्यूल में ट्रांसफर करने के लिए एंड उतनी ही फास्ट ये साउंड ट्रेवल करेगी. सो व्हेन अ साउंड वेव ट्रेवल थ्रू अ मीडियम इट कॉजेज द मॉलिक्यूल्स टू वाइब्रेट और इन सॉलिड जो क्लोज पैकिंग है एंड स्ट्रॉन्ग फोर्स इट अलाउ दीज वाइब्रेशन to be transmitted quickly and efficiently to the neighboring molecules. While in the liquid, the weaker force and the greater mobility of molecule, it lead to slower energy transfer. वहीं gases में large distance between molecule and lack of strong force, it result in very slow energy transfer. तो यहाँ पे जो main important thing है that is because of the closely packed structure in the solid and strong intermolecular force, there is faster transfer of energy from one molecule to another और उसकी वजह से speed of sound is maximum in the solid medium. Speed of sound, it is affected by two properties of the matter, the elastic property and the inertial property, and the relationship between them can be described by the following equation. So the velocity of the sound, it can be calculated by under root of elastic property divided by the inertial property. Elastic property is related to the tendency of a material to maintain its shape and not deform whenever a force or stress is applied to it. And the inertial property, it is related to the material's tendency to be sluggish to change in its state of motion. And The density is an example of the inertial property. Let us see few examples to understand the elastic property of the medium. A material such as steel, it will experience a very small deformation of shape when a stress is applied to it, and it is considered to be a rigid material with a very high elasticity. While in other case अगर हम रबर की बात करें, it is highly flexible. मीन्स अगर थोड़ा सा भी फोर्स इस रबर बैंड पे या रबर पे लगाया जाए तो इट विल गेट डिफॉर्म और इट विल चेंज इट्स शेप readily. So a small stress on the rubber band, it causes a large deformation. So the steel, it is considered to be a stiff or the rigid material, while the rubber band, it is considered as a flexible material. अगर हम पार्टिकल लेवल की बात करें तो अ स्टिफ और अ रिजिड मटेरियल इट इज कैरेक्टराइज्ड बाय एटम्स और द मॉलिक्यूल्स हैविंग द स्ट्रॉन्ग अट्रैक्शन फॉर ईच अदर. अब इसकी वजह से क्या होता है कि जब भी उस मटेरियल पे कोई फोर्स अप्लाई किया जाता है इन एन अटेम्प्ट टू स्ट्रेच और डिफॉर्म द मटेरियल, तो जो स्ट्रॉन्ग पार्टिकल इंटरेक्शन है इट प्रिवेंट दिस डिफॉर्मेशन and it helps the material to maintain its shape. So the rigid materials such as the steel, they are considered to be having the high elasticity. Inertial property is related to the resistivity of a medium towards the changes. So अगर किसी भी मीडियम के इंडिविजुअल पार्टिकल का इनर्शिया ज्यादा है, इट मीन्स व्हेन द वाइब्रेशन और द फोर्स और प्रेशर इज अप्लाइड टू दिस पार्टिकल, तो ये अपनी प्लेस से मूव नहीं करेगा. सो इन दैट केस दे विल बी लेस रिस्पॉन्सिव टूवर्ड्स द इंटरेक्शन, बिकॉज अगर ये यहाँ से मूव नहीं करेगा तो दिस एनर्जी विल नॉट बी ट्रांसफर टू द नेक्स्ट मॉलिक्यूल. So they are less responsive towards the interaction between the neighboring particle, and in this case will be having the slower transmission of the wave. So density is one of the example of the inertial property, and the substance which is more dense has more mass per volume. Dense material, they transmit the sound slower, because if a material is more dense, it means the molecules within this material are either larger or they are heavier. So as the sound, they are the vibration made up of kinetic energy. So it takes more energy to make the large molecules vibrate in comparison to the smaller or the lighter molecules. पर जस्ट अभी हमने देखा कि जो वेलोसिटी ऑफ साउंड है दैट इज डिस्क्राइब्ड बाय दिस इक्वेशन वेयर वी आर हैविंग द इनर्शियल प्रॉपर्टी इन द डिनोमिनेटर. इसका मतलब कि अगर डेंसिटी कम है तो वेलोसिटी ऑफ साउंड ज्यादा होना चाहिए, अगर डेंसिटी ज्यादा है तो वेलोसिटी ऑफ साउंड कम होना चाहिए. तो इस इक्वेशन के हिसाब से अगर हम देखें तो सबसे कम स्पीड जो साउंड की है दैट शुड बी इन द सॉलिड मीडियम, बिकॉज सॉलिड की जो डेंसिटी है दैट इज मच हायर in comparison to the gaseous medium. So even though the inertial factor favor the gases, जो ये elastic factor है this is having the greater influence on the speed of a wave. So अगर हम medium को compare कर रहे हैं तो वहां पे elastic property is one of the dominating factor in describing the velocity of the sound. And in general, solids have the strongest interaction between the particles, followed by the liquids and then gases. And because of this reason, the longitudinal waves, they travel faster in the solids, then उससे कम liquid में and सबसे कम gases में. तो जब हम different medium की बात करते हैं, उस case में elastic property is the most important factor in defining the speed of the sound in different medium. But within a particular medium, the inertial property of the density has a greatest impact upon the speed of sound. तो अगर हम एक पर्टिकुलर मीडियम की बात कर रहे हैं either in the solid or in the liquid or in the gases, तो in a particular medium their inertial property play important role. लेकिन अगर हम अलग अलग मीडियम को कंपेयर कर रहे हैं उस केस में इलास्टिक प्रॉपर्टी इज द मोस्ट डिफाइनिंग फैक्टर. So sound it travels at a slower rate in the more dense object if they have the same elastic properties. So here we have the speed of sound in different material. Some of the medium are taken as example: air, water, gold, brick, wood, concrete, glass, steel and aluminium. And for understanding the impact of the density on the speed of sound, we have included three examples here. Aluminium, it is having the density of 2.7 gram per centimeter cube. You can see here that aluminium having the less density, it is having the maximum sound speed. Steel, it is having the density of around 7.85 gram per centimeter cube. It is denser than aluminium, and we can see that speed of sound is less in the steel. And the density of gold is 19.32 gram per centimeter cube at the room temperature. And here we can see that the speed of the sound, it is less in comparison to the steel and the aluminium. So if a material is having the more density, in that the sound will travel at a slower rate. Same applies for the liquid and the gaseous medium also. Here we have the speed of sound in the different gases. So sound, it propagates faster in the low molecular weight gases like the hydrogen. But if we compare the speed of sound for the helium, methane and nitrogen, we can see that as the molecular weight of these gases increase, the speed of sound, it decreases. And for a given ideal gas, the molecular composition is fixed, and thus the speed of sound, it depends only on the temperature. So here we have the example, dry air, both are the dry air, but here we are having the variation in the temperature. So we are having the similar molecular composition, but here we are having the variation in the temperature. This is at 20 degrees Celsius, and here we are having the 25 degrees Celsius. So here the speed is 343 meter per second, but as the temperature increases, the speed of sound, it increases to 346 meter per second. And also the humidity in the atmosphere, it increases the sound propagation, because the moist air, it allows the sound to travel slightly faster than the dry air, because when water evaporates from the earth's surface, the water vapor molecules, they replace the nitrogen and oxygen molecules in the dry air. And as these water vapor molecules are lighter in comparison to the nitrogen and oxygen, the vibration will be faster, and thus the speed of sound will be more. As the speed of sound depends upon the density of the material, and the density, it depends upon the temperature, there is a relationship between the temperature in a given medium and the speed of sound in the medium. And here we have the equation for the air at the sea level. So the speed of sound is given by this equation. So 331 meter per second under root 1 plus temperature in Celsius divided by 273 degrees Celsius. So this equation can be utilized when we are having the temperature in the Celsius, and this is equivalent to this particular equation जहाँ पे 331 meter per second under root Tk, that is the temperature in Kelvin, divided by 273 Kelvin. So we can see here that the temperature, it is in the numerator part. So more is the temperature, more will be the velocity or the speed of the sound. So the sound, it travels faster in the warmer air, because the molecules, they vibrate faster at higher temperature, and it allows the sound wave to propagate more quickly. Now if I ask you whether the sound is a longitudinal or a transverse wave, the most obvious answer will be the sound is a longitudinal wave. But wait, you have to first see whether a medium is defined or not. If a medium is not defined, then our answer should be the sound is a longitudinal wave. But if a medium is defined, the answer should be chosen correctly. So the sound, it travels as the compression type wave, that is the longitudinal wave, confined to a plane in the fluids, that is the gases and the liquids. But along with the longitudinal wave, an additional type of wave occurs in the solid, that is referred as the transverse wave, and also known as the shear wave, because it is similar to the earthquake wave in the earth surface. And this transverse wave occur only in the solid, because solids can support the elastic deformation. So you can notice here we are having only the compression or the longitudinal wave, but here we are having the longitudinal as well as the transverse wave in the medium. So in solid, the sound travel both in the form of the transverse and the longitudinal wave. So now we have this clarity that if a medium is the gas or a liquid, then the sound wave is the longitudinal wave. But if a medium is a solid, the sound wave is both longitudinal as well as transverse wave. So these are the references from where the content of today's video have been taken. We will meet soon in the next video. Thank you.